when we're looking at the blood types, we have that A, B, AB, and O. So A and B antibodies are codominant, are they not? Because if they both show, they're both expressed. But the O is recessive to the A or the B. Does that make sense? And because of all of that, you have multiple alleles, because you have three different versions. You have A version, B version, and the O, the recessive. Okay? So if I had someone with AB blood crossing with O blood, what are the offspring possibilities? Well, the AB is IA, IB, and the O is little I, correct? So the possible genotypes would be phenotypes would either A or B, correct? And they'd both be heterozygous. We're good with that? If you have A blood, okay, there's a marker on the red blood cells that says, I'm A. Okay? And in your body, your immune system is very good at recognizing things that do not belong. Okay? And if your body recognizes something that does not belong, then it'll attack it and kill it. Okay? That's what it does. So if you get a bacterial infection, what does your body do? It goes into kill mode as soon as it can. If you have a virus and it recognizes it, it goes into kill mode as soon as you can. And some of the symptoms are you get a fever. The fever is not the bacteria attacking you. The fever is you raising the body temperature to try and kill the bacteria to slow it down. Okay? The pus coming out of a wound. Like if you have a wound, that pus is dead white blood cells that are trying to kill off what's there. Okay, so your body is really good at recognizing stuff that does not belong. If you go in for a kidney transplant, if I take a kidney out of someone else and put it in you, what does your body automatically do? It looks at it and says, you don't belong here, kill you. Okay? So if you do get a transplant, most of the time you have to go on anti-rejection drugs to keep from rejecting that organ or whatever. When it says I'm an A, and you insert B blood, let's say you had to go into the hospital and they insert B blood into you. What's going to happen? What do you think, Spar? And then we'll go over it. Yeah. It's going to reject it. And B blood is also going to try and reject the A blood. They're going to fight at each other. Because A blood's going to go, but you're B, you do not belong here, I'm going to kill you. And then you can get very sick. Okay? So when you go into a hospital, you can't just go in and they just give you, that's blood off the shelf, and they throw it in you. Okay? If they don't have time to type your blood, because you need it stat, what are they going to do? They're going to pump O blood into you. Because O blood, when it goes into you, has no marker that says, I'm A or I'm B. It's kind of like, my blood. And it just circulates around. And hopefully by the time that is going around and helping you, your body is reproducing enough blood to keep it going. Okay? But O has to receive O. Okay?
Why is it that we can't
in addition to saying I'm B, and it attacks it and tries to kill it off, we have another factor that's called the RH factor. Okay? This is a second, I'll say protein, other than the A's and the B's, on blood cells. Okay? And with that, you're either Rh positive or Rh negative? Positive, what does that mean? So if you're positive, you have the protein. Okay? And it's also a dominant trait. Okay, if you're Rh positive, you're dominant. Okay? If you're negative, you don't have no protein. And it doesn't matter. If you're negative or positive, it does not matter. Okay? Where it comes into play is if a mother is negative and a father is positive. Okay? If the mother's negative and the father is positive, in the first baby, if they have more than one baby, it becomes a concern. The first baby is not normally a problem. Okay? But if you have a negative blood and you expose positive blood to it, so you have negative blood, let's say you're negative, you expose positive blood to it, your body says it's positive, it's going to send a message saying it's not yours. And if it's not yours, it is going to, well, just in terms of, in general, you're going to develop antibodies against it. You're going to develop antibodies against it. And so your body's going to attack it. Anytime it's exposed to a positive blood, it now has memory to say, kill it. Okay? Does that make sense? So the first baby is usually good. Okay, so the first baby, usually not a problem. It's the second baby if the child, if the mother is negative. And if the first baby was positive and there's a chance that it is, then you've got issues. All right, let's put this together in terms of the simple genetics, and we're going to do what's called a dihybrid cross. And in the dihybrid cross, we're looking at two independent genes okay? And you have to predict what the outcome is going to be. So in terms of the two independent genes, you may have, let's say, an AB negative parent 1. We'll call that the mom. AB negative. And we're going to cross it with an O positive male. And we're going to say the positive is, what are we going to say? Heterozygous or homozygous? We'll go hetero? Okay. Now that we have two genes acting upon, we have to look at two genes for the Punnett square as opposed to just one. So now instead of having just one allele in each one of those boxes, you're going to have two, with 2 makes 4. Okay? So let's do the genotype for this. This would be IA, IB, little r, right? Because it's negative. And then over here would be II, big R, little r. So you guys can see that? So it's IAR, IAR, IBR, IBR, all little r's, all capitals. And over here you've got those options. Ask me questions if you don't see that. So when you look at the next one, you would have like this, and let's go back, and it's IA, IBR, IA, R, IB, R, IAR, IBR. And what was this one? I big R? I small r, I big R, I small r. So if we do this, this would be IAIRR, IIARR, IBIRR. Do you guys see now you're filling them in? So those are your genotypes. I'm going to let you fill them in. But if I had IAIRR, what is the phenotype for that? This one. What's that phenotype? So it'd be an A positive blood, yes. So that makes a lot of sense now. You guys are pretty good with this. So if I gave you another problem with 2 alleles, you could solve that problem.